Hi, my name is Alan Falk. I represent a company called What Now Energy. We have worked together with our partners in the Middle East to design a street lighting and surveillance system. As we are Victron resellers, we've based our design on a smaller version of Victron Energy inverter. The requirements are quite unusual. Normally street lighting solutions are DC based, but in this case they require 90 watts of AC. So we'll be using a small inverter to provide the AC, and we'll also be using gel batteries as opposed to lithium to cope with the extreme temperatures that are required by the spec. So I'll quickly take you through the layout of the design, and then I'll take you through a prototype that we've built where we've done physical testing and some of the parts that we've emulated, so we can ensure that the project is successful, stable. And I'll also take you through how we're using the Victron VRM, the Victron monitoring portal, to manage these devices remotely, and our confidence in the product itself. Victron's a Dutch-based company. They manufacture devices all over the world. Some are made in India under license, but they're extremely robust. They have a fantastic reputation. Most of their products has 5-year warranty, and we'll be using just smaller versions of both the inverter and the MPPT controller in this project. Okay, so here's a diagram of how the system is set up and configured. This pole, or this graphic, represents 2 square meter solar panels, 450 odd watts each, giving you about 920 watts of total solar power DC. Obviously in a street lighting scenario, normally DC is preferable, but in this case, because we need AC, we need to add an inverter. So the input feeds into a Victron MPPT controller. That in itself will charge the batteries. The batteries are not shown in the slide. We've chosen gel batteries, AGM gel batteries, because they can take the heat that's required. And obviously lithium would be first choice, but they're not able to sustain that 60-70 degrees required temperature tolerance. So the MPPT controller then feeds the batteries, and the batteries go into the inverter. The inverter inverts out to 220 volts, 230 volts AC, and then it goes into a 100 VA AC transformer, stepping down to 24 volts AC. Both the MPPT controller and the Victron Phoenix inverter are connected via a VE bus, Victron Energy Direct Bus, through to a USB adapter into a Raspberry Pi. The Raspberry Pi itself then communicates through Ethernet or Wi-Fi to the Victron monitoring portal, the VRM, through a secure connection and a secure account that now allows this device to be configured, and it also allows the device to be controlled remotely, and things like dusk to dawn street lighting programs can be set up on the MPPT controller itself. So this is the kind of nerve center of the control. This is the design, and I have now built a prototype which I'll demonstrate to you working in a live environment. Okay, here's a quick simulation. You can see we've got 26 volts, 24 volt battery system going into the inverter. We turn the inverter on. You'll see load goes through the AC transformer. We emulated the load by running a number of these halogen 50 watt bulbs. So we're putting about 3 or 4 amps on this side, which emulates the 100 or the 90 watts at 24 volts of AC that the client requires. And then this data is being fed back into the Raspberry Pi and sent up to the cloud, where it can be monitored and you can see the load. So this is what the VRM portal looks like in a typical solar installation. You have the grid over here, and AC loads represented over here. Critical loads that are fed by the inverter are indicated over here. The power comes in from the solar MPPT controller into the inverter, into the batteries that you can see here are charging. These are lithium batteries, and supplying the critical loads and the AC loads. The actual inverter has the capability of blending those two power sources from both battery and grid at the same time. And then the total consumption is registered over here. There are obviously many different other things that can be read. So this is, for example, a graph showing the battery discharge overnight and recharging during the day, the total consumption, and there are many other components to this application. So you can go and look at consumption graphs and see what percentage comes from solar and battery. Obviously, there's no grid on this project, but this is an example of how this works. So I've set up an installation over here that actually is for this particular project. So here you will see the actual inverter running that I showed earlier. So this is the current battery status sitting at 24 volts. Going through the inverter, there are no AC loads running at the moment, and you can't see the MPPT controller, but this is the type of view that you would have. There are other features like the MPPT controller can be programmed for street lighting, so you can set dusk to dawn or dawn to dusk, and various on and off timers, and a whole host of other parameters. This is done through the remote control console that gives us access to the actual device itself. This one is not online at the moment, but I can show you an example of what that looks like by just choosing another site. So just go back to the previous dashboard, and you can have a look at the remote control. This gives you access to the actual device itself. So it's both a graphical display and also gives you all of the statistics that you require. It takes a little while to connect. And this allows us to remotely configure the device. It doesn't seem to be connecting at the moment. Might have to try another site. This is another reference site, and let's just see where the remote control will work here. Should be able to get online. Here we go. So this will show you all of the characteristics of this installation. Obviously, this is a much more sophisticated installation, but it shows you all the statuses, and you can actually go through and look at all different types of configurations. So I can actually choose the MPPT controller, and I can see the incoming current, the DC voltages, the state of charge, all of those parameters. So this is all part of the portal. It's a secure portal. It's very informative, and the graphical display is obviously really useful.